alcohols is another one. And then we have alkanoic acids and carboxylic acids. So alkanoic acids and carboxylic acids are the same thing, and is the same name, the same group, okay? Now, each series has what we call a functional group. And who can define or tell me what is a functional group? What is a functional group, class? Hello, students? What is a functional group? No answer, nobody knows? All right, a functional group is a group of atoms, or it's a group or a specific type of bond that determines the chemical properties of the compound. So a functional group is a particular group of atoms or bonds that determine the chemical properties of the compound. So for example, we have, we have here alkanes, and their functional group is the carbon-to-carbon single bond. For alkenes, their functional group is the carbon-to-carbon double bond. For alcohols, their functional group is the hydroxyl or the OH group. For alkanoic or carboxylic acids, the functional group is the COOH group. All right. We also learned that when you're naming the compounds, you have a specific ending for each homologous series. So for alkanes, all the compounds end in -ane. For alkenes, all the compounds end in -ene. For alcohols, all the compounds end in -anol. And for carboxylic acids, all the compounds end in -anoic acid. All right. So now we're going to talk about when we can look at the compound and we can tell what homologous series it is from. So we can look at the name of the compound to tell what homologous series it is from. So let me just give you a quick example. Let me just give you a quick example. So here we have pentanol. Can you tell me which homologous series pentanol is from? Hello, students. It's 8 o'clock in the morning. I am sure that you.
It's the Miss, can I look back at the
Yes. There are 4 homologous series: alkanes, alkenes, alcohols, and alkanoic acids.
Yes, Miss, it's alcohol. It's the OH hydroxyl group.
Right. So you have to look at the ending of the name. So all alcohols end in -anol. So this is from the alcohol group. Okay.
Yes,
what
Miss.
about pentene?
It's an alkene. It's an alkene.
Very good. It's from the homologous series of alkenes. What about pentane?
Alkane.
It's from the homologous series alkanes.
It's ethanoic alcohols or something like that.
No, it's called alkanoic acids.
Oh, alkanoic acids. Okay, got it.
And an old name, this is an old name for it, but they still use it today and they still put it on the exams, and it's called carboxylic acid. All right, so you can look at the name, namely the ending of the name, and it will tell you which homologous series the compound is from. All right. You can also look at the formula. Now, for each homologous series, they have what is called the general formula. That means Cn, meaning the number of carbons, for alkanes, H2N plus 2. That's the general formula. So all alkanes have this general formula. So let me show you what I mean. The general formula for alkanes is CnH2n plus 2, where N is the number of carbon atoms. So say for example, this alkane has 4 carbon atoms. How many hydrogens would it also have? Well, you use the formula. 2 times 4 plus 2 would give you how much? It would give you 2 times 4 is how much, class?
8.
4 is 8 plus 2 is what?
10.
10. So it would give you C4H10. Let us look at this alkane. Suppose it had 6 carbon atoms. How many hydrogens would it have?
Oh, so it's 6 times 2, 12 plus
12
2,
plus 2 is
14.
14. Suppose it had 3 carbon atoms. How many hydrogens would it have?
8.
8. All right. So I hope you get the idea that each homologous series has a specific general formula that all the compounds within that series will follow the same formula. So you can literally look at the formula and you can tell that this is an alkane because it follows this general formula CnH2n plus 2. All right. Now, for alkenes, the general formula is CnH2n. So let us look at some examples of what the formula will look like. So for alkenes, it's CnH2n. So if you have 4 carbon atoms, how many hydrogens would you have in an alkene? How many hydrogens would you have, class?
8.
8, because it's 2 times N. If you have 6 carbons, how many hydrogens would you have?
12.
You would have 12. And if you had 3 carbons, how many hydrogens would you have?
6.
You would have 6. All right, so that is it for alkenes. Now let us look at what alcohols have to say. So for alcohols, the general formula is CnH2n plus 1, and then you have an OH group attached to that. So let us see what those formulas will look like. So for alcohols, it's CnH2n plus 1 plus an OH group attached. So suppose you have 4 carbon atoms. What would be the number of H's? What would be the rest of the formula? C4H what?
H. You times it, miss? You can times it? 8.
So 2 times 4
9.
is 8 plus 1 is 9. And then the OH attached. So this is what this alcohol would look like.
Oh.
Suppose you had 6 carbons. How many hydrogens would you have? How many hydrogens would you have? 2 times 6 is what?
12.
Plus 1 is
13.
13. And then you have the OH attached. Students, I want you to participate in our only here tetralone. And here's the deal. This, I don't know if I will be able to get this class back because I'm using my phone and I'm not sure where it's recording to. So if you think you can just walk away and do your own thing and then watch this later, that is not the case because it is not being recorded properly. For some reason, I'm having some difficulties. As a result, pay attention. That's all I'm saying.
Excuse me, miss.
Go ahead.
They will always give us the number of carbon atoms.
Usually.
Okay.
All right, so this one is C3H what? Why would it take so long to answer? 3 times 2 is what, class?
That's 6. 7.
6 plus 1 is what? Is this hard? Who is finding any difficulty with this? I don't understand why I have to wait at least 2 minutes to hear an answer from somebody. Why is that? Is there any difficulty? Can you explain to me? All right, let's look at alkanoic acids. Now for alkanoic acids, their general formula is CnH2n plus 1 COOH. So let's write that down. CnH2n plus 1, and then they have the COOH group. So say, for example, you have 3 carbon atoms. So how many hydrogens would you have?
6 would it be?
So 2 times 3 would be, N is 3, right? So 2 times 3 is 6, plus 1 is 7. And then you have the COOH group attached. Suppose you had 4. How many hydrogens would you have?
Would it be 9?
Would be 9, and then you have the COOH group attached. Good. So as you can see, for each homologous series, you have a general formula. Okay? And these general formulas are the same for all. It doesn't matter the number of carbons. So if you have C11, the number of H's, sorry, would be 22 for an alkene, right? If you have C50, the number of H's for an alkane would be 50 times 2, which is 100, plus 2, which is 102, right? So it doesn't matter the number of carbons you have. As long as you apply the formula, you will know how many hydrogens and as well as the functional group that is attached to it. So now, when you have the formula, so you're going to work out the formula from the name. You're going to first determine the homologous series which the compound belongs to by looking at the name, and then you're going to look at the number of carbon atoms. So take a look at this example. Pentanol. Pentanol ends in anol. That means it belongs to the homologous series of alcohols, and the general formula is CnH2n plus 1 OH. So who can tell me what is the formula for pentanol?
C5.
So pent means 5, so it's C5. And if you have C5, how many H's will you have?
11.
12.
11. Because it's 2 times 5 plus 1 is 11. And then you add the OH here, right? So you can look at the name and it will tell you automatically the formula. Let's look at another one. Let's look at pentene. Who can tell me what does pentene look like? Pentene is from which homologous series?
Alkene.
It's from alkenes. And alkenes have the general formula
C5.
So yes. would it be-
CnH2n. So what would pentene look like?
C5H10.
C5H10. Very good. All right. So that is how you can look at the name and know the formula. Now, we're going to see how we can look at the formula to know which homologous series it is from. So tell me, where is this compound from? Which series? Is it an alkene, an alkane, an alcohol, or an alkanoic acid?
I think it's an alcohol.
It's an alcohol. Why do you say that?
Because the formula would be N plus N, and then the H would be 2N plus 1. So it would be 4. 4 times 2 is 8, plus 1 would be 9.
Right. And the easier way is just anytime you see an OH group, that is the functional group of alcohols. So all alcohols contain an OH group at the end, and that is how you identify alcohols. All right, tell me the name of this alcohol. Tell me the name of this alcohol, class.
Quadranol.
So
That was just a
So
guess.
it has
Because
four carbons, mean it is bute.
So it's butanol.
Butanol. All right, let's look at this now. C3H7COOH. So what homologous series does this compound belong to?
Alkanoic acid.
Very good. It's an alkanoic acid. And or a carboxylic acid, that's the other name for it. All right. Now we're going to talk about determining the name of the compound from the formula. So you're looking at the formula, you're going to tell me the name. Oh, tell me the name of this compound first. No, the thing that you must remember is that for alkanoic acids, you need to count up how many carbons it has. How many carbons does this compound have here?
Where?
It has 4. Even though you see a C3 here, remember this C right here, so you see it? So you have to count it too. So what would be the name of this compound?
Butanoic acid.
Butanoic acid. All right, so look at this one now. What is the name of this compound? How many carbons does it have?
3.
3. And the prefix for 3 is prop. So what's the name of this compound?
Propanoic acid.
Propanoic acid. All right. Are we all on the same page? All right. I don't hear no answer, but just moving on. So now we're going to talk about structural isomers. And iso is the prefix that means the same. So structural isomers have something in common, and that's what we're going to look at now. So structural isomers are compounds which have the same molecular formula, but different structural formula. And remember, what does the structural formula look like? It looks like this, right? Where you draw out all the carbons and all the hydrogens. That's what a structural formula looks like. It's not focusing. And then what does a molecular formula look like? The molecular formula looks like this, where you just write the number of carbons and hydrogens that are there. So there are some compounds that have the same molecular formula, same number of carbons, same number of hydrogens, but their structure is different. All right. So structural isomers, again, have the same molecular formula, but different structural formula. Now, because of this, then we have some things that are similar with structural isomers and some things that are different. So if the isomers contain the same functional group, meaning if they are both alkenes or both alkanes or both alcohols or acids, then they will have the similar chemical properties, but they may have different physical properties. But if they contain different functional groups and they belong to a different homologous series, they will have different both chemical and physical properties. Because remember that the functional group is responsible for the chemical properties and how they react. So if they have the same functional group, they will have the same chemical properties. But the physical properties will be different because they will look different. However, if they are from a different functional group, they will have different everything. They will have different chemical properties and they will also have different physical properties. So let us look at what we mean. So this is a diagram of the isomers of pentane. Now pentane has 3 isomers, C5H12. All of them belong to, do they belong to the same homologous series or different homologous series, class? Look at the structures and tell me, are they in the same homologous series or different? Hello?
Different.
They're in the same. Look, all of them have single bonds. So all of them are alkanes. You see that? All of them are in the same group. Do you understand what I'm asking? And do you understand the answer?
Yes, miss.
Yes, miss.
Right. All 3 of them are in the same group. As a result, will they have the same chemical properties or different chemical properties?
Same.
Same.
Same chemical properties, because if they're in the same group, they will react in the same way. However, if based on what you're looking at in their structure, you can see that the physical properties are different because they physically look different. All right. Somebody wanted to say something? All right. So we're going to look at each isomer now. Same, all of them is C5H12. Look, 1, 2, 3, 4, 5 carbons. 1, 2, 3, 4, 5 carbons. 1, 2, 3, 4, 5 carbons. So all 3 of them have C5H12, and I'm not going to count the H's, but just trust me, that is 12. And then that is the same molecular formula, but they have different structural formula. So we call these isomers. All right. Now, as you can see, for this isomer, it's a straight chain. All 5 carbons line up in a straight line and they are bonded like that. For this isomer, you have 4 of the carbons in a straight chain and 1 is branched off. And for this isomer, you have 3 of the carbons in a straight chain and 2 of them are branched off. All right, but again, all of them have the same molecular formula, but the structure and how they are bonded are different. So that is what we call isomerism. Now, it is important that you don't get tricked, and CXC love to do this. Is this a straight chain, class, or a branched chain?
Straight.
Branch.
Okay. I understand why you would say branch because it kind of looks like this one, but it is indeed a straight chain because there is no unbroken, there's no unbroken line going straight. So you can literally draw a straight line and they just curve the line, come down, right? So this is a straight chain and they do it like this to fool you. Right? So this and this is the same thing. You only get branches when you are going in a straight line and then you have to branch off. So if this carbon was here, then it would be a branch. But this is actually another way of drawing a straight chain.
So Miss, you're saying that it's straight chain if it branches off at the end?
Oh yes. Oh yes. Because it's not really a branch, right? It just turned the corner. It's not really branching off. It's just straight and then it turn a corner. So it's really a straight chain. All right. So
Yes, Miss.
that is that. Now, before you go, and look here, guys, I sent you some homework and but only one person sent me the activity. One person. Look at that. I saw no feel. No feel like someone can just not do no work and pass. Okay.
Yes, I didn't even know you did that.
Sorry?
I didn't even know you sent work.
Yes, look in the group. You need to look in the group. I sent the notes and I sent the work. This is the work I sent. So let us go through it quickly. Name the following. What is the name of this compound? First of all, what homologous series does it belong to?
Alkene.
It's an alkene because it has a double bond. So how many carbons does it have?
3.
It has 3. So what's the name of this compound?
Propene.
Propene. All right, let us look at this one now. What's the name of this compound? How many carbons does it have?
It's 2. It will be in. So wait. No. It will be
So 2 is F.
ethanol. Because
So it's not an alcohol.
It's ethane.
It's not an alcohol. It's a carboxylic acid. COOH. It's from the group.
Acid.
It's from the group of alkanoic acids. So it's ethanoic acid.
So Miss 2 is F.
2 is F. You have to memorize them. All right. How many carbons does this one have? 1, 2, 3, 4. 4 is what?
Butanoic acid.
Bute. And look, it's bute. And which homologous series is it from? Which group is it from?
It's alcohol, I think.
Alcohol. Very good, because you have the OH group here. So if it's 4 bute and it's from alcohol, what's the name?
butanol.
Butanol. Good. And this one now, 1, 2, 3, 4, 5, 6, 7, 8 carbons. What group is this from?
Come on, Reggie, you know this. Answer,
Which group?
Johnny. It's
Which group? Which group is it from? Which homologous series?
alkene.
No, it
Alkane.
doesn't have any double bond. It's an alkane. Very good. If it's an alkane, what's the name? If it has 8 carbons, what's the name?
Miss octane.
Octane. You ever hear about high octane? This is how it looks. All right. What about this one?
Butane.
What homologous series is this from?
Miss alkene.
So it's an alkene. So what's the name?
Butene.
Butene. Good. All right, so that was the homework. Now, I'm going to be having classes this Sunday. So when you come back this Sunday now, we are going to learn how to name things that have branches like
miss.
this. Yes?
What time on Sunday?
It's going to be at 2 o'clock, from 2 o'clock to 3 o'clock.
Oh, okay, miss.
Yes. You're going to learn how to name branches like this. What do you call this? So we're going to learn how to name branch chain isomers, and we are going to just continue on with our organic chemistry. I don't know, maybe we'll go back to school next week, Monday. It sounds like that to me. And if so, then we'll just continue with our topic. And if we have to stop to do a review for the mock exam, then we will, so that you can be prepared for that as well. Do you have any questions about what we studied today? All right. Well, if not, then have a
Yes.
peaceful. Yes.
What is an isomer exactly?
An isomer, structural isomer, they have the same molecular formula, but different structural formula.
Okay.
Same molecular formula, but different structural formula. So pay attention to the WhatsApp group. I'm going to take a picture of these notes and put them in the group for you so that you can have them to go over. All right. Remember, please come back on Sunday at 2 o'clock so we can continue with our lesson. Okay, everybody?
Okay, miss.
All right. Have yourselves a peaceful and productive rest of your day. And remember, I think class has finished and you can go on to your next class. I don't remember the exact timing, but I think our time is up. So you can go on to your next class quickly because all the sessions will be fitted in before lunchtime today. All right. So
Bye, miss. Happy Teacher's Day, best teacher.
Thank you. Take care.
Yes.
Bye.
Bye, miss.
Bye-bye.